Hello everyone. Today I will show you how must be done the ROETEST tube tester calibration. This calibration is easy to do. The software helps us very much. Anything we need is a calibration box. This one, just some resistors, load for current calibration. Not so nice, but it's very good. This calibration box has a switch. This position is to set the drop from heater or filament voltage. As you know, when we supply a bigger tube, 1, 2, 3, 4 amps for filament, on the lines, on the circuit that supply the heater, will drop some voltage. So at the tube socket and on the tube pins, we will not have the same voltage as it is supplied from the device. So moving this switch on this position, we set the compensation that the device will make on filament voltage. This calibration box will be inserted here. We remove the 9-pin adapter and insert it here. We have some like this. Put the socket and it's okay. Now I must dismantle the lower side of the case to have access to the adjustable resistors to make the calibration. I dismantled the case and the ROETEST can be seen. A short description of the interior. Here is the main transformer, auxiliary transformer, some supplies here, 5 volts stabilizer, and the plates, boards, main board, relay boards, 10 relay boards. This one, each with 1, 2, 3, 4, 5, 6 relays, make the connection between suppliers and the pins to the tube. This is the 600 board. In fact, it delivers only the 300, but will be connected in series with the 0 to 300 voltage for the plate, the anode. Next one is the heater stabilizer, anode stabilizer, screen stabilizer, G3 stabilizer. These deliver 0 to minus 100 volts for some special multi-grid tubes which needs negative voltage for G3, and this is a G1 first grid stabilizer. Here we have the communication board, USB communication. Here we have the power transistors. Here we have the sensor for temperature for the heatsink, microprocessor board, and this is the main part of the tube tester. For calibration, we need the calibration box. I showed it to you before, a good voltmeter and ampere meter. This is BM869, a very good one, very high accuracy. And the software will help us very much. Multimeter is connected to the calibration box at the voltage socket. We have voltage, common, ground, and current. Go to the software, go to the C part and option test. So it's not connected. We don't have a connection between. We'll stop it and restart. Oh, the device will not turn on. I turned on the device and now start the software again. And after that we will have the connection between the devices. It starts. Go to C section, option test. Easier way to see the connection between the software and the device is to check one, look here, fan relay, and the fans start. Okay, we go to sending voltages and we test here the calibration assistant. It's a wonderful feature of this software. And here it shows us a calibration box, nicer than mine, and all calibration that must be done. Voltage, 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 voltage. Oh, I forgot. Before this calibration, we must calibrate two internal voltages. We have here two voltages, as you see, 330 volts and 105 volts. And let's check them. .330 voltage, it's okay. For so low difference we don't need to readjust. And 105, as you see, is good. It's minus 105. Is good, this voltage too. We don't touch them. And let's check the 5 volts too. 5 volts, where is the point? To check, here is the point. We have 5025, is very good. And let's go to the calibration box and to the calibration assistant. We start with heater voltage as you see, it shows us how to connect the calibration box with the multimeter. Go start. And show us adjust this trimmer. How nice. It showed to us in the picture where we need to make the adjustment. So you must adjust the trimmer so that the multimeter shows the following voltage: 100 volts. As you see here on this voltmeter, we have 100 volts. It's okay. And on multimeter, it's 100.02. Wonderful. Last calibration was made 4 or 5 months ago, but I checked it from time to time, 1 time per month or 2 times per month. This is okay. Go to compensation. No, continue. Adjust the trimmer so the virtual instrument the same voltage as the multimeter, 100 volts. Multimeter shows us 100.03. This one 100. Variable 0 to 1. It's wonderful. We don't touch this. Continue. It says adjust the ROETEST button so that the multimeter shows the best voltage. At best, the following, the closest value from 2 volts. Multimeter shows us 2.0055 is excellent. We don't touch anything, or else we should work from this slider, plus, minus, and plus. From this must be made adjustment, but is good by calibration. Continue. Please enter the voltage shown on the multimeter. 2.0060. It rises a little. It's okay. So we enter here 2.008 and continue. Repeat using continuous synchronization of top button. It's achieved. And we are already ready. Now we go to the plate voltage. For current, we should move the connection to the multimeter, for multimeter to go to the amps, and at the calibration box to the current connection, and to not move the wires so often. We go first with the voltages, and after that with the currents. Voltages for anode. It shows us to add the connection. Touch start. Adjust trimmer so that the multimeter shows the following voltage: 300 volts. Wow, 300.0 doesn't matter. It's wonderful. Continue. Virtual instruments shows the the same voltage as the multimeter, 300 volts. We have here 299.96, and the next step is 303. It's okay, don't touch this. 2, continue, adjust the buttons. The best following voltage on the multimeter, 12 volts. And we have 12,038. Let's check in the plus. 1 minus 3, again minus, too low. It was very good. Continue. Please enter the voltage shown on the multimeter. Let's see. It should be 12 volts, but it's not possible. So the device, the ROETEST, compensate this by software. We enter now the 12.034. It memorized that 0.034 is the difference, and we use this difference, this offset, for the future. 12.034. 12.034. Continue. Repeat using continue until synchronization is ready. Now 600 volts board. Start. Adjust voltage with trimmer to 300. It's 300.14. I don't think this small difference needs adjustment. It's 0. Point less percent. Continue. Please select that. Is 600 volts board. It's over. GDOI voltage. Start. If you noticed, it shows us from where we need to make the adjustment. Adjust trimmer so that the multimeter shows the following voltage, 300 volts, and multimeter shows 300.09. Maybe I dismantled the ROETEST for nothing. I think not needed calibration. Virtual instruments show the same voltage as the multimeter. Multimeter 300.1, and the virtual very, very good. I don't touch anything. We go again here. Continue. Adjust buttons on the multimeter. The closest value 12 volts. 11,986. We'll wait for it to be stabilized. So we touch a plus. Plus is 0.7 more. A minus is very good. 0.03 was okay. Continue. Voltage shown on the multimeter, 11.976, 11.976. 976. Continue, repeat using, we don't need because we don't have differences. Read this. G3 voltage is less used, this voltage, but must be calibrated. Start. Just trim it minus 50 volts. We have minus 50.040. It's okay. Continue. Virtual instrument shows the same voltage as the multimeter. We have here minus 50.038. Here we have exactly minus 50. So this calibration, it's okay. Continue. At best the following voltage minus 2 volts. Minus 2.0011. I don't need to make adjustments. Continue. Just trim the multimeter shows minus 2 volts. It's okay. Continue, enter the voltage shown on the multimeter. 2.001. Continue and ready. And now the G1 voltage is the most important voltage for all tests. We'll start. Just trim the multimeter shows minus 50. As you see here, is very good. Don't need to. Virtual instruments show the same voltage. Minus 50.03 is very good. In fact, it's a little variable. It's very good. No need to work on it. Continue. Just buttons. At best, minus 2. We have 1.9991. We don't need to touch the trimmer. Continue. Adjust trimmers, minus 2 volts is very good, very close. Enter the voltage shown on the multimeter. 19991. 1.999. Another digit it don't accept. Continue. Ready. Now we go to compensation. Done. Compensation. Voltage measurement. Go start. We need to push button in calibration boost for connected resistors 3.3 ohm 25 watts. Adjust voltage on multimeter with trimmer to the same values as without resistor. So without resistor we have 6.309, and with the resistor a little lower. I forgot the first voltage. .309. Let's identify the trimmer. This is the heater board. As you see here, we see the trimmer. The heater board is the closest trimmer to the relay. It was 309. Oh, too much. I think this is 309. So with that resistor, 308, 308, it's okay. The filament is not so sensitive to feel 1 microvolt. Continue. So we are ready with the compensation. We go to the heater current, 640 milliamps. Must set the. You must move this wire to the current connection, and from multimeter to milliamps max 0.6. It's a little at the limit, but I think the fuse will not burn. It makes some noise because not a good. This is okay. We push start. Just reminds that the virtual measuring instrument show the same current as the multimeter. Oh, is 276.05. Here we have 276.49. It's a half of milliamp, is not so important, but let's do it. This is the trigger we must adjust. On heater plate is the first one at the edge. This one is. It's higher, lower. This is 27604, 27604. It's okay. This is ready. Continue. The current shown on the multimeter. Let it be stabilized. 42508. So 42 point 5. It's not so stable. It's good like this. Repeat until synchronization is achieved. It is not so important. Filament currents to be so precise, so it's okay. Current 6 amps. multimeters to amps. We move this one to this hole. It's okay. And goes to push the start. Virtual measuring instrument shows the same current as the multimeters. Multimeter shows 1.9 46, 1.9 44. Not a big difference, but let's set it. Is the second trimmer on the heater board. $1948. Very small difference. Too much. It's okay. Continue. Now let's go to the plate current. This is more important. One. Here I sense a little difference. Not much. 0.2 milliamps. Not such important for EL34, but for an HCC83 equivalent 12HA7, 0.2 milliamps means it's more important. Let's go start. Virtual measuring shows the same as multimeter. Let's see what's virtual. 24.9. As you see here, 25.1. I think entire calibration I make is only for this difference. 25.12. Not a big difference, but is a difference. We have to work at the first trimmer on the A plate. A plate is this one, and the first trimmer is this. So we need to follow the 25.12. I think we are here. So the multimeter shows 25 1 through 6, 25 1 to 4 is the closest calibration I can make. It's enough. 2 microamps is not so much. Continue. Enter the current shown on the multimeter. 0.2. 0.202. It's okay. offset was saved. Continue. Let's do it another time. Virtual show the same as multimeter. 25 11 25.3 is not so good. It shows too much now. This is good. Continue. Value on the multimeter 0.203, 0.203. Continue. Let's check another time. Here we have 25 1 2. Here we have 25 1 2, 27 23. It's okay now. Continue. The value on the multimeter 0.203, 0.203. Continue, and we are ready with the plate current adjustment and higher section of the plate current. 300 milliamps. It's okay for the same scale on multimeter. Maximum 300 milliamps. We'll start. Just remember this one, virtual metering, the same as multimeter. Here we have 149.74, 149.42. Is the second trimmer on the A plate. This one. We adjust a little until we have on the here 149.7. $71. It's okay. 72. This is good. Continue. Enter the current shown on the multimeter. 34.88. So 34.885. Continue. We must repeat another one another time. 149.72, 149.73. It's okay. That's good. Continue. What shows the multimeter? 34.89, 34.89. It's okay. 89. Continue. Ready. We finished with the plate current. Let's go to G2 current. Start. This one must show like this one. Fine. 5.496. 5.496 is excellent. We don't touch anything. Care și un multimeter 0.040 1 0.041. It's okay. Let's check another time on the multimeter. 5.496, 498. It's okay. 2 microamps is nothing. Continue. 0.041. 0.041. Continue. Ready. We finished with the lower range of G2 current. We have more higher range of G2 current. We'll start. Virtual measuring instrument shows the same current as the multimeter. I have here 48. 405. 10. We have here 0.01 difference, very low difference. 417, 426, 41. Let's adjust a little lower. The trimmer we must work is the second from the G2 plate. Here is the second trimmer. So 425. It's actually 426. 426, 428. 2 microamps are not important. Continue. The current shown on the multimeter 6.24. So 6.241, 240. Continue. And is ready. So this was the calibration. Without a calibration box, it's very hard to make the calibration. Not impossible, but with you need a load for each current. You can use a bulb, light bulb, or power resistors, but it's much easier with the calibration box. As you have seen, the calibration for so much time was kept very well. We just a little readjustment was needed to be done to the plate current. All the voltages were perfect, currents the same, only one difference to the plate current, about 200 microamps. It's not a big difference. Many tube testers, this value for many tube testers, this value is a joke. They didn't feel such difference.